In this video, we're going to be learning about some trigonometric ratios. So these are the current tools that we have, and all of these things we use to solve for some missing sides of a triangle. So the first tool that we have, and we might know from last year, is the Pythagorean theorem. So this is used when we have two sides out of the three sides in a right triangle. The second tool that we currently have is we can use our knowledge of similar triangle proportions if we have examples like shadow casting problems, or examples where maybe we have a value like x and we have this value, and if we knew that this was like 3 and 15, right? We can then use, in examples like this where we can't use Pythagorean theorem, we can kind of relate this other triangle to it and use our similar triangle proportions, right? So these are two very different skills because it's different given information from each triangle. Now, what if we don't have the information that we need to use one of those two skills? So take a look at this diagram right now, and the question is to solve for A in the diagram below. So here we have a triangle, we're looking for a missing side. So let's see if we can use any of the two skills that we have. Can we use the Pythagorean theorem? Well, remember, for the Pythagorean theorem, you need 2 out of the 3 sides. We only have one side. So no, we can't. We need 2 sides. At least, well, yeah, you need 2 sides. Can we use our knowledge of similar triangles? No. For similar triangles, you need at least 2 triangles. There's only one triangle here. So the skills that we have can't even be used for this, and we'd be left in the mud. But that's what this unit is for. So what even is trigonometry? Well, trigonometry is a study of math that deals with the relationship between sides and angles. So it's going to help us solve problems like the one in the previous slide. Now, some new symbols for this unit. This Greek letter, it looks like a circle with a little line in the middle of it. That symbol stands for theta. That's how you say it. And what theta is it's the standard variable that's used for missing angles. So you want to make sure you are filling this in your notes. There are blank spaces here. And again, theta is the standard variable that we use for missing angles. Similar to how we use x. Usually we use x all the time when we're talking about missing sides. But in trig, when we're talking about missing angles, we use that variable theta. Now, similarly to this, we also use this theta that we're using. This angle that we're using is usually called the reference angle, and that reference angle is going to change depending on the question that we have. So these are the trigonometric ratios that we are going to be using throughout this unit. So you want to make sure the ratios are written in for you, but you have to, or the names of the ratios are written, you have to actually write the fractions in there. So I'm going to tell you guys how to pronounce each of these. So there are 3 of them. The first ratio is sine of theta. That's how you read this. Sine of some angle theta is equal to the opposite side over the hypotenuse. Now, if you go in this diagram here, in this case, our theta is right here, right? So in this case, theta is equal to the opposite side over the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse, and again, you can reference this diagram to see which sides we're talking about. And then the third trigonometric ratio is tangent of theta is equal to the opposite side over the adjacent side. Now we're going to get into some examples in this next slide right here. So in these examples, we're going to be finding sine, cosine, and tangent of angle A. Now in this case, angle A is going to be our reference angle. So just directing you guys to this shortcut is something that can help you remember the trig ratios. So it's SOHCAHTOA, and you can even rewrite it in this little fancy fashion because it kind of gives you the fraction, right? So we know sine, for example, is opposite over hypotenuse. So if you write it SOH, you can kind of see that sine is opposite over hypotenuse. Same thing for cosine. Cosine is adjacent over hypotenuse, so you can write it as CAH. And then tangent is opposite over adjacent. So those shortcuts can help you But let's get into these examples. So again, we're finding this, our reference angle is angle A. So we want to make sure we label that in our diagram. Put a little arc on angle A so you know that is your reference angle. You can even go as far as filling that in as theta. Now, what you need to be able to identify from this reference arc is where your opposite side is and where your adjacent side is. Because the hypotenuse is never changing, right? The hypotenuse, you know the hypotenuse of your right triangle is always across from this right angle. So I know that AB is always going to be my hypotenuse. And I'll even label that. You guys should be doing the same on your diagrams. Now the opposite side is, you can go similarly to how we find the hypotenuse, right? The hypotenuse is opposite of the right angle. So to find that, we draw an arrow from that right angle, right? So it's the same idea. So let's do this in a different color. So from our reference angle here, if we want the opposite side, we draw an arrow straight across. It's the side that's furthest away from it. So in this case, when A is our reference angle, BC is opposite. So we want to label that in our diagram as well. And for sine, we don't even need the adjacent side, but adjacent just means next to. So we'll get into that for cosine and tangent though. So for right now, sine of theta is equal to the opposite side over the hypotenuse. Now the opposite side in this case is BC. So sine of A is equal to BC over the hypotenuse side, which is AB. Now if we had actual numbers, we can write the numbers in, but for now we're just using segment notation here. Now cosine of A, again, we want to make sure we are marking our reference angle. And for cosine now, we need the adjacent side and the hypotenuse side. So again, the hypotenuse is never changing. No matter where your reference angle is, the hypotenuse is not changing. Now our adjacent side is the side, it has to be touching the angle, right? So our reference angle is here. We have two sides that are touching that reference angle. This side, right? And this side. However, your adjacent side cannot be AB, because AB is already the hypotenuse. There's never going to be things that count for more than one side. So if AB is already your hypotenuse, it cannot be the adjacent side, which leaves us that our adjacent side is right here. And then in this case, our opposite side would be BC, but we're not worried about that right now. We're worried about our adjacent side and our hypotenuse. So cosine of A is equal to adjacent side, which is AC, over our hypotenuse, which is AB. And you guys want to make sure you're following along with these in your notes. And then last but not least, tangent of angle A, we want to mark our reference angle here. And for tangent, we want the opposite side and we want the adjacent side. So the opposite side, we go straight across from our reference angle. This side is opposite. And we want to get in the habit of labeling our triangles. Just like I'm doing here, you guys should be doing the same thing. Now again, our adjacent side is the side that's touching your reference angle. That is not the hypotenuse, right? So in this case, AB is touching our theta, but AB is the hypotenuse, so that cannot be the adjacent side. The adjacent side is right here. So filling in our ratio, we have opposite, which is BC, over our adjacent side, which is AC. And again, if we had numbers in here, we can go ahead and fill those in, but we don't, so we are sticking with segment notation. Now in these next examples, you guys are going to see how the reference angle affects the opposite and adjacent sides. So in this case, we're going to be using angle B as our reference angle for all of them, but we're still going to find sine, cosine, and tangent. So angle B we want to label as our reference angle. So now we want the opposite side and the hypotenuse. Again, hypotenuse is never changing. I usually label that first so that we don't get confused. But opposite, I'm going straight across from my reference angle, so my opposite side is AC. Now for sine of angle B, it's opposite, which is AC, over hypotenuse, which is AB. Cosine of theta, or in this case cosine of angle B, since angle B is our reference angle, we want to label that. For cosine, we need adjacent and we need hypotenuse. So again, I usually label my hypotenuse first, because otherwise we can't mix that up right now. I know my adjacent side needs to be touching my reference angle, but it obviously can't be side AB because AB is already accounted for with the hypotenuse. So my adjacent side is going to be over here for BC. So adjacent, which is BC, over our hypotenuse, AB. Last but not least, tangent of angle B. Again, we label our reference angle. We want the opposite side, so we're going straight across and labeling that as opposite. and then we want our adjacent side. Now this is interesting, but again, think about this. Your adjacent side can never also be your hypotenuse. So your adjacent side, look for the sides that are touching your reference angle. In this case, we have AB and BC. But AB is already the hypotenuse. So our adjacent side has to be BC. So tangent is AC over BC. Wonderful. So big takeaways here. You want to make sure the same exact way you need to be labeling before you write your ratios. You are labeling your triangle, labeling your reference angle, labeling your opposite side and hypotenuse side, and labeling your adjacent as well. All right, can the 90-degree angle be used as our reference angle? Let's test this out. So I'm only going to do one or two of these. But let's say we wanted to use our 90-degree angle, which would then be angle C, right? Angle C would be our theta in this case. So sine is opposite over hypotenuse. So to find our opposite side, we would go straight across from our reference angle. So our opposite side would be AB, right? So this would be our opposite side over our hypotenuse. Well, this is the issue. The hypotenuse is also the opposite side. So technically it would be AB over AB, which would be 1, and that does not work, right? So in this case, we have two sides that are trying to account for more than one thing, and that just doesn't work. And let's just see the case with cosine as well. So cosine is adjacent over hypotenuse, right? So again, we have our hypotenuse here, but now there are two options for adjacent. Your adjacent side, again, you look for the sides that are touching your angle, right? So this side is touching our reference angle, and this side is touching our reference angle. And neither of those are the hypotenuse, so there's not really a problem with labeling any of them as the adjacent. So technically, both are adjacent. And again, that is a problem. You can't have something accounting for more than one thing. And quickly, I guess I'll just do tangent. Tangent is opposite over adjacent. And again, it's the same idea, right? Your opposite side is over here, which is okay, but then you have adjacent sides here and here. So we wouldn't know really which one to choose, right? So no, the 90-degree angle can never, ever, ever, ever be your reference angle. So in that case, what I mean is you're never going to have something like sine of 90, like to write a ratio for, or cos of 90. You're not going to have to write that ratio, or tan of 90. You're never going to have to write that ratio out. They are equal to something, but you're never going to have to write that out as. Like if you have to choose a reference angle, it's never going to be the 90-degree angle in this case. Some quick other examples here. You can also work backwards. If you're given the ratio, you can label your triangle from that. So if sine of A is 3/5, so again, we want to label that this is our theta. Sine of A is 3/5, label the triangle accordingly. Well, remember that sine is the opposite over the hypotenuse. So if sine of my angle is 3/5, I know that my opposite side is 3, and I know that my hypotenuse is 5. So again, my opposite side, I can label that as 3, and my hypotenuse, which is over here, I can label that as 5. Now, the question might even go extra and say, hey, using the fact that sine of A is 3/5, find the adjacent side, or find AC, right? And in this case, from this, we can use Pythagorean theorem here, but we're not even going to go there. All right, one last example. If tangent of B is 8/12, label the triangle accordingly. So now we're using B as our reference angle. And again, tangent is opposite over adjacent. So in this case, 8 would be the opposite side here. And then 12 would be our adjacent side. Now be careful again, right? Our adjacent side can never be the hypotenuse, so our adjacent side would have to be over here, and we'd label that as 12. All right, so that's it for this video. Make sure you guys know and try to use this shortcut. Remember this shortcut, what I usually do is I write this out on top of every single problem that I do, just to get it in my head. So if I have a question, I'll just write TOA without even knowing which one I'm using, because that's going to help me. Then I can use process of elimination, and it also helps you remember it.